Okay, I'm going to go over the Unit 7B review. So basically the first six problems, we're going to be graphing these, making sure that we scale the axes. We're going to figure out the amplitude, the period, and the reference point. So let's first off do the first problem here. Let's go ahead and figure out what the amplitude is. Now remember that the amplitude is always positive. So I'm going to go ahead and write the values here. So my A value here is the absolute value of negative 5, 5. That's the amplitude. Now, A is actually negative 5. I should write amp. Amp is 5. Okay. So our amplitude is 5. Oh, that looks terrible. Amp. Actually, yeah. Amplitude is 5. I'll write that down instead. And then our period. To find the period, use a formula. And the period is 2 pi, because the normal curve takes 2 pi for the full cycle, divided by the b. b is in front of the x, and what's in front of x is pi. So the pi's cancel, that means my period is 2. And then we want to find the reference point. The reference point, basically what we're going to do is we're going to let the value that's after sign in parentheses, which we don't really have a parenthesis because there's nothing being added there, that's going to equal 0. So pi x equals 0. And if pi x equals 0, divide by pi, that gets us 0 for the x. And there's nothing out here, so that's 0. So this is going to be our reference point. And since this is sine, sine starts on the reference point. So I'm going to go ahead and put a dot at 0, 0. And now we're going to scale the x and y axes. When you scale it, you have to make sure the whole thing fits. So notice the period doesn't have a pi, it's just the number 2. So we want to make sure that this has a length of 2 from here to the right before we actually kind of end it. So since I want to go to I don't want to go 1, 2, because that means from here to here I'd have to do the whole sine curve, and it's kind of really small. So I'm actually going to spread it out a little bit. I'm going to go 1, 2, like go by halves. So this is 1, that's 2, 3. You can write negative 1 if you want. So that's my x-axis. My y-axis, I know that I'm going to start at 0 and I'm going to go up and down 5. So I'm going to go by ones. 1, 2, 3, 4, 5. This is my 5 here. 1, 2, 3, 4, 5. This is my negative 5 here. All right, let's go ahead and graph this. So I'm going to start at 0, 0. I'm going to end a period of 2 away from this to the right. 1, 2. That's where it's going to end. Remember, the sine curve also will hit the middle of those 2 points right there. And then between the first 2, right here, I'm going to use my a value. Since this a value is negative, that means I'm actually going to go down 5, down to here. Between the 1 and the 2, halfway between that, I'm actually going to go up 5. Okay? And then I'm going to go ahead and draw my sine curve in, make sure it's kind of like a U, and then this side is a U shape, so it's not going to be straight lines. And that would be considered one cycle. The amplitude goes up 5, down negative 5. Notice it goes down first because it's negative. And then the period, which is the distance between the first point and the ending point, is a distance of 2. That's your period. All right, let's try number 2. Okay, number 2. Let's go ahead and first start off with the amplitude. Amplitude is always positive. And here my amplitude is 3. It's already positive 3 for A. All right, my period, our formula is 2 pi over B. 2 pi over, and B is 2 pi. So this has a period of 1. All right, a reference point. So I'm going to set what's after this cosine, make that equal 0. 2 pi x equals 0. If you solve that, you get x equals 0. And there's no plus or minus, so that's also 0. So we're going to start at 0, 0. And from here, I'm going to scale this. Now I need to go to the right by 1. But I like to have at least 4 sections. So I'm actually going to go by fourths. 1, 2, 3, 4, that's my number 1. 1, 2, 3, 4, that's my number 2. And then you're going to go up and down. Starting at 0, you're going to go up and down 3. So I'm going to make this go by ones. All right, let's go ahead and start. Remember that the cosine does not actually start on the reference point. This is just a guideline for you to actually graph it. So think of this as like an open circle. This is your midline. It's actually on the x-axis. So cosine does not start there. It starts above or below that reference point. Since it's a positive 3, we're actually going to start above. Go up 3, that's the starting point. Okay, that's just a reference point. That's a starting point. And then a period of 1 away. So 1 to the right. That's where it's going to end. In between these two, there's no dot here. We're going to go past the midline. Don't stop at the midline. Keep going past the same value, 3. And now in between these 2 points, I'm going to be on the midline. Between these 2 points, I'm going to be on the midline. And remember cosine, see how if I stop here, see how there's an actual curve there? It's not a straight line. And then draw your curve. That's that parabola. And then again here, don't just go straight to that. I will mark off if you go straight to that. You should have some sort of a curve there. So if I cover that up, you'll notice that I see a little bit of a curve there. Okay. Let's go ahead and take a look at the next one. So the next one is negative sine of pi over 2x. So let's go ahead and start off with the amplitude. So the amplitude is always positive, and since that has a negative there, that's really a negative 1, so the amplitude is just 1. It goes up 1 and down 1. The period, we're going to be using our 2 pi over our b, and our b happens to be pi over 2. So we have this over pi over 2. All right, let's go ahead and take this and simplify it. Notice that I have a 2 in the denominator, so I'm going to multiply the top and bottom by 2 to get rid of that. And I'll notice I have a pi and a pi there, that'll get rid of that. So it's really 2 times 2, so this is going to have a period of 4. All right, the reference point, we're going to set our pi over 2x equals 0, and pi over 2x equals 0 gets me x is 0. And there's nothing added or subtracted on the end, so that's also 0. All right, let's go ahead and take a look at, so let's go ahead and take a look at the scaling of this. So I'm going to start 0, 0 here, and I want to go out a period of 4. So I'm actually going to go by ones. 1, 2, 3, 4, right there. And remember starting at 0, 0. Amplitude is 1, so I'm going to just go up. I'll go up to 1 here and negative 1 here, so I'll go by halves. All right, let's go ahead and start the graph. So we're going to start at 0, 0, and this is actually sine, so it's actually on the graph. This reference point is on the graph. We're going to go 4 to the right, that's length of a period of 4. Halfway in between is going to also hit that midline. And now here's where we have to decide. Between the first two, should we go up or down? And if you take a look, don't look at the amplitude. Look at the actual equation. The a value is negative. So we're going to go down 1. And then between the last two, we'll go up 1 because there is a negative there. So that's the curve. All right, let's go ahead and take a look at this next one here. So we have cosine, and we have an a value of 1/2. That's already positive, so the amplitude is 1/2. We're going to figure out our period, and our period is taking our b value, which is in front of x, that 1/4. So it's 2 pi over 1/4. Let's multiply top and bottom by 4. That cancels, so it's really going to be a length of 8 pi. Wow, that's a lot. All right, let's go ahead and solve for our reference point. In the reference point here, we make what's in the parentheses equal 0, so 1/4 x minus pi over 8 equals 0. Means I have to add the 1 or pi over 8 to the other side. And to get rid of 1/4, I'm going to multiply both sides by 4. 4 over 8 reduces. 4 goes into 8 2 times. So x equals pi over 2. And then outside the parentheses is a +1. So that's +1 there. Oops. There we go. All right, let's go ahead and let's start scaling this. So when we scale this, we know that we're going to start at pi over 2 and then go an additional 8 pi. So 8 pi, that means I have, let's see, 1, 2, 3, 4, 5, 6, 7. I have exactly 8. So I'm going to actually go by 1 pi for each. So this is 1 pi, oops, that's 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. I'll just put 8 pi just so you could see where it's at. Oh, I probably will have to make this a little longer because we are going to start at pi over 2 before we go to the right. So I'm going to go ahead and make that longer a little bit. Okay, so that's 8 pi right here. And then let's go 1, 2, 3, 4 just to get an idea where we're at, 4 pi there. And then we have our values that go up and down. So we're going to start at 1 and go up and down a half from there. So I'll go by halves. So this will be 1, and then this will be negative 1. Oops, wrong color. Oh well, that's okay. All right, so what I'm going to go ahead and do is start at my reference point, which is pi over 2. So I'll be in between 0 and pi. And then I'm going to start up 1. Now keep in mind, this is not the graph. That's the open circle. That's the reference point. It's not on a cosine graph. That's the hard part. I'm going to draw my midline. And this graph will be above or below that open circle where I started. So where do I start? Well, since that is my value of 1/2 is positive in my equation, I'm actually going to start half up. Remember that I went by halves. This is 1/2, 1, 1.5. I'm starting there, and then I'm going to end 8 pi away from that. So if this is a length of 8 pi right here, I want to just go half over, because remember this started at 1/2 of a pi, so I'm 8.5. So I'm going to end right here. All right, let's find the middle of these two. So if you want to, you can kind of say, okay, half of 8 was 4, so it's like 1 over from that. That might help. Now keep in mind that this is where it's in between the two, but don't go to the midline. You want to go past it by half. All right? Between 4 pi is 2 pi, but we're over by half because it shifted all to the right by half. So I'm going to go to the midline. And between 4 and 8, I'm going to go over to the midline again. And then from there, you can go ahead and draw. Okay. Let's go ahead and take a look at the next one. And space-wise, I don't think that's going to work with looking at the equation. So I'm going to slide this underneath it. Okay, so let's take a look at number, oh, wrong one. Let's take a look at number, what? I think I wrote this wrong. 1, 2, I did, that is, wow, Riza. I can't. Oh well, that's okay. Hopefully you guys followed what I just did there. I completely went 1, 2, 3, 4, 5, 6. I'm like, why did I go back and forth between sine and cosine? Well, anyways, we have all the problems here. Hopefully you guys can see what happened here. So technically, this was number 1, and then this one right here was actually number 4, and this one here is number 2, and then this one here that I just did was number 5. So now we're going to go and do number 3. And then number 6 will be actually number 6. Okay, now that I got this together, sorry about that. Now I'm going to go ahead and take a look at my sine. Okay, let's start off with our amplitude. So it's a 2. That's positive already. All right, our period is 2 pi over b. And 2 pi over, the b is what's connected to the x, it's 1/4. All right, to get rid of that 4, I'm going to multiply top and bottom by 4. That cancels. So this is another 8 pi deal. All right, and then I'm going to go ahead and find the reference point. So I'm going to set what's in the parentheses equal to 0. I have x over 4 minus 3 pi over 4 equals 0. All right, I'm going to go ahead and move the 3 pi over 4 to the other side by adding it. So it's positive 3 pi over 4. And then from there, I'm going to get rid of the 4 by multiplying top or left and right by 4. That cancels. So x is actually 3 pi. So it's going to start at 3 pi, and then look at the equation. There's nothing added on the end, so it's 0. 3 pi 0 is where we're starting. Okay, so I'm going to go to the right 3 pi, and then I'm going to go another 8. So if you add 8 and 3, that's a total of 11 pi that I'm going to go to the right. All right, maybe I'm going to have to scale this quite a bit down. Let's maybe go by 2s. 2, 4, 6, 8, 10, 12. Yeah, I guess I can go by, maybe I can go by 3s. No, I don't like going by 3s. 2, 3, 4, 5, 6, 7. That's 8, 9, 10, 11. I'm just going to extend it and go by pi. So not go by pi at the store, but I'll go by 1 pi for the axes here. All right, so here we go. So this is going by 1 pi. 1, 2, 3. This is where my 3 pi is. So then go 3, 4, 5, 6, 7, 8, 9, 10, 11 pi. That's 11 pi right there. So notice, whoa. See if I can get this to work. All right, let's try that again. Okay, so 3 pi is where I'm going to start, and then I'm going to go to the right another 8 pi. So 3 plus 8 lands me at 11. I don't know if you can see that 11. Okay, now what I'm going to do is scale my y-axis. I'm going to start at 0 and go up by 2 and down by 2. So actually I'm going to just go by 1. So that's my 2, and that's my negative 2. All right, let's start the graph. So I'm going to start at 3 pi 0. I'm going to go a distance of 11 pi to the right. I'm sorry, distance of 8 pi to the right, which lands me at 11 pi. And then, wait, let's see. In between of these two, so if you add these together and divide by 2, that's where you'll know you'll stop. 11 plus 3 is 14. Half of 14 is 7. So 1, 2, 3, 4, 5, 6, 7. That's going to be the middle. And then between these two, I'm going to either go up or down. And here it's a positive, so it's positive 2 up. Between these two, I'm going to go down 2. And then that's going to be the curve. Okay. And the last one is a cosine, which is not going to start on the reference point. Okay, so let's go ahead and figure this one out. So we have, let's do, amplitude, that's 3/4, it's already positive 3/4. And then we have to find the period, which happens to be 2 pi over the b, which is 2. And 2 pi over 2 is just pi, so this is going to be a distance of pi. And then from here, I'm going to go ahead and find the reference point. All right, to solve for this, I'm going to go ahead and make that equal 0. So 2x plus 2 pi over 3 equals 0. I'm going to move this 2 pi over 3 to the other side. That makes it negative 2 pi over 3. And then from here, I'm going to divide by 2, which is the same thing as multiplying by a half. So that cancels, and actually these 2's cancel as well. So x is negative pi over 3. So negative pi over 3, and outside the parentheses, there's a minus 3. So I'm going to start it down 3. Okay, let's go ahead and scale. I know I'm going to start at negative pi over 3, and then from there I'm going to go to the right a distance of pi. So let's go by pi over 3's. So let's go ahead and go to here, and that's we'll go 1, 2, 3, and that will be 1 pi. Okay. And then we'll go 1, 2, 3, and that'll be 2 pi. I have to go negative direction because it's negative. 1, 2, 3, and this is a negative pi. Now scaling my y-axis, I'm going to start at negative 3, and then I'm going to go up and down from that 3/4. So I'll go by ones. So this will be 2, I should say negative 2 and 2. All right, let's go ahead and graph this. So I'm going to be drawing a midline, and then I'll be drawing it above and below that midline. So let's start off with negative pi over 3, which is over just by 1. And then from there, I'm going to go down 3. 1, 2, 3. There's an open circle. This is just the midline. I am not actually going to be drawing or using that point part of the graph. So where do I start? I actually start above this by 3/4. So this is going by ones. So 3/4 is just right here. And that's positive 3/4. So we know that starts up. And then the distance away from that should be 1 pi. So from here, this is by thirds. So 1/3, 2/3, 3/3. So that's a distance of pi away. I'm going to stop right there. All right, in between these two, so I'm kind of right here in the middle, you go past the midline by 3/4. And then in between these two, I'm going to go ahead and put a dot on the midline. So, oops, this is like at -1 and this is at half. So between those two, it's going to be kind of a little bit closer on this side right here. And then same thing over here. Between these two, this is not like a distance of 1 to go to half. It's closer by a quarter there. And then okay. All right, let's go ahead and do these other 4 graphing. So here we have, ooh, you can kind of, I was trying to pre-make these, but you can kind of see through. Darn it. I'm going to have to get another graph paper. Hold on a second. Okay, got a new piece of graph paper, so here we go. We are going to do tangent now. So now we're going to find our period, period, reference point, and asymptotes. Okay, so let's start off with the period. I'll write it underneath here. So remember the formula is different for tangent. It's pi over b, not 2 pi. Pi over b, and our b value is in front of the x, which is 3. So this is going to be actually pi over 3 for our period. And then from there, I'm going to go ahead and figure out my reference point. To figure out your reference point, you have to make what's inside here equal 0. And when you solve, x is 0. And there's nothing outside, so that's 0. So 0, 0 is your reference point. Keeping in mind, we'll go half to the right and half to the left of this. And then we want to find their asymptote, which I'm going to write the equation after we draw this whole thing. All right, let's go ahead and figure out our scale factor. So since I'm going to start at 0, 0, and actually that's the coordinate right here, the origin, I want to go half of this to the right and half of this to the left. So half of pi over 3, it's like multiplying by 1/2. That's pi over 6. I want to go pi over 6 to the right and left, but I want to leave myself some room in between. So I'm actually going to make this be pi over 6. And this be pi over 6. Negative, I should say, pi over 6. All right, and then I want to start at 0, and I'm going to go up a half and down a half. To give myself some room, I'm going to make this be half right here, and let this be a negative half. All right, let's go ahead and graph this. So I'm going to start at 0, 0. And then half of pi over 3 is pi over 6, and that's going to get me my asymptote here. Actually, let me draw this out with the green. My asymptote will be at pi over 6 and at negative pi over 6. All right, and so my graph is going to start at 0, 0, and in between here and the pi over 6, right in between that, I'm actually going to go up a half on the right, and then between this reference point and the asymptote, halfway in between, I'm going down a half. Okay. All right, let's try number 8. And number 8 is actually, here, let me do this. Number 8 is here. I'm not going to do what I did last time. All right, here we go. So for this, I'm going to find my period, which is pi over b. And b here is 1/5. So we're actually going to multiply top and bottom by 5. And that gets me 5 pi. Okay, 5 pi is my period. So keep in mind, half of this will be to the right, half of that to the left. So I'm going to go 2.5 to the right, 2.5 to the left. All right, write a reference point. Oh, I forgot to do the equation of the asymptote up here. Let me redo that. Sorry, I'll get back to this one in a minute. I forgot to do the reference point here. Or, not sorry, not reference point, the asymptote. We have to write the equation of the asymptote. So the equation of the asymptote, it's x equals, and you pick either one of these two. I'll pick pi over 6. You start with the actual asymptote value for x, and then plus or minus the period times n. The period is pi over 3. So pi over 3 times n. Okay. All right, now we'll go back to number 8. All right, number 8, the reference point, we need x and y. So here what I'm going to do is I'm going to make this x over 5 equals 0, so x is 0. And there's nothing outside of that, so it's 0. So 0, 0 is the reference point, and then we're going to go a distance of 2.5 to the right, 2.5 to the left, because we want to split this in half. All right, knowing that this is negative 4, from the reference point, I'm going to go up and down 4. So actually, I'll go by ones. 1, 2, 3, 4. Oh, whoops, wrong color. Dang it. Let's get here. This is 4. And this is 1, 2, 3, 4. This is negative 4. I know I'm going to go half to the right, half to the left. So let's make this be worth 1 pi for each. So this is 1, 2 pi. 1, 2, so that will be negative 2 pi. Keep in mind, it's not going to go 2 pi and negative 2 pi, because that's only 4. We need 5. So we're actually going to go by a little extra from that. Let's go ahead and draw our asymptotes. So from the reference point, which is at 0, 0 here, we're going to go to the right 2.5. So this is 1, 2, and then half. So this is going to be my asymptote. It's in the middle. And then here's 1, 2.5. See how the distance between this and that is 5? 2.5 pi plus another 2.5 pi makes a total of 5 pi. All right, now what we're going to do is we're going to graph this. So we're starting at 0, 0, and then halfway between this point and the asymptote. So what's half of 2.5? That's basically 1. I can't even think. So half of 2.5 is 1.25, so 1.25 this way. And keep in mind that this is a negative 4, so we're actually going to be down on the right side. So it's like 1.25 here. And this one's going to be 1.25, but we're going to go up 4 on this side because of the fact that that's negative. And then the equation of the asymptote, I'm not going to forget that like I did last time. So the asymptote, you start with x equals, and then we're going to start with either one of these two. So you could use positive 2.5 pi or negative. And technically, usually in radians, we don't like to write it as decimal. So instead of writing 2.5 pi, 2.5 is the same thing as saying 5 pi over 2. Okay? It's like going by halves. 1 half, 2 half, 3 halves, 4 halves, 5 halves. Plus or minus. And then we are going to add the period, which is 5 pi, times n. All right, let's go ahead and do number 9. Number 9 is looking at the, down here. So we're going to look at the value of our period first. So period is pi, not 2 pi, pi over the b. And on this one right here, the b value is 1. So this is just a normal pi. All right, to find the reference point, we're going to make this inside here equal 0. And that gets me x equals negative pi. So negative pi, there's nothing added on the end, so that's 0. So we're going to start at negative pi 0. And then we're going to go to the right half of pi and to the left half of a pi. So that means when I scale it, I'm actually going to go by halves. Well, maybe I'll skip one and go by an extra half so that we can have a little bit more room. So I'll go 1, 2, 3, 4, and this is going to be where my negative pi is. And then let's scale the y values. So the y values is going to start at 0 and then go up by 2 and down by 2. So I'm just going to go by 1s. All right, let's draw on our asymptotes. So our reference point is at negative pi 0. So negative pi 0 is right here. And then we have to take half of the period to go to the right and the left. Well, half of pi is basically pi over 2. And then half to the left, so I'm kind of writing it right into my work. But these are the two asymptotes. And then, if you notice, this is a full distance of pi. That's the period. So now we're going to graph this. Halfway between this reference point and the asymptote, we're going to go up 2. Halfway between this reference point and the left asymptote, we're going to go down 2. So, kind of paper moved on me there. Okay. And then the equation of the asymptote, I'll write it on this side. So we start with x equals the actual value of these asymptotes. So this is at negative pi over 2, or I can do negative 3 pi over 2. I'm going to use this one here. Negative pi over 2 plus or minus the period. And the period happens to be pi times n. All right, and then the last graphing one, actually I'm going to put this on the side of it here. So we can do that last one there. Okay, so here's number 10. So from this one right here, let's go ahead and figure out our period, which is pi over b. And on this one, the b value is, oh, look, there's a 3 out in front. That's actually the b. If you distribute it, you'll get 3x minus 3 pi. So that's actually 3. So the period is going to be pi over 3. My reference point, I'm going to go ahead and start with the inside here, make that equal 0. And so we get x equals pi. And then outside is a 4. So pi 4. That's where it's going to start. And then from that, I'm going to go ahead and graph it, or scale first. So I know I'm going to start off at pi, and from that pi, I'm going to go to the right and left half of this. If I multiply 1 over 3 by 1/2, it's pi over 6. So let's see if I can go by 6s. If I go 1, 2, 3, 4, 5, 6 pi, that's 1 pi. So let's go ahead and do that. That's going to be pi. So I went by pi over 6s. 1, 2, 3, 4, 5, 6. That's a pi. All right, and then scaling going up and down. This is going to start at 4, and then from that go up and down 2/5. So I'll go by ones. 1, 2, 3, 4. And then we'll go ahead and find our asymptotes. Well, let's find our reference point first. So we're at pi 4. That's the point where we're going to start. Now we're going to go to the right and the left half of this, which is pi over 6 to the right. So we went by 6s. So pi over 6 to the right of that, and pi over 6 to the left of that. So pi over 6 plus pi over 6 is 2 pi over 6, or 1/3 of a pi. That's what our period length is. All right, I know this is going to be really skinny, but that's okay. From here, halfway between this point and the asymptote, we're going to go up 2/5. So since I went by ones, 2/5 actually doesn't go up very much. And then between this point and the left side asymptote, halfway in between, I'm going to go down 2/5. Okay. And then let's find the equation of the asymptote. So we start off with x equals and pick one of these two. Now I know I didn't write down what those values are, so it doesn't matter. I'll pick this one. So this is 1, 2, 3, 4, 5, 6. So 5 pi over 6 plus or minus the period, which is pi over 3n. All right, the rest are going to be writing the equations from the graph. So let's go ahead and start off with this first one. We want the equation of the sine curve. So to find the equation of the sine curve, we first have to know our amplitude, our period, and then our reference point. So let's start off with the amplitude. Notice from 0 goes up by 1 and down by 1. So this is actually your A value here. A is going to equal positive 1 because it starts up for sine. All right, let's go ahead and figure out our period. So our period is the distance between the first and the end of the curve. So from here to here, how far is this? So notice it goes by pi over 6. So that's 1, 6, 2, 6, 3, 6, 4 over 6. And 4 over 6, I'll actually write that down. 4 over 6 reduces to 2 pi over 3. So that's actually our period. That's not what b is. Now the formula for finding the b value is 2 pi over the absolute value of b. That equals the period. Not the p, the period. The period equals 2 pi over b, because remember sine is 2 pi. Cosine is also 2 pi, same formula. But tangent is pi. All right, let's go ahead and take a look at the p, which is 2 pi over 3. I'm going to go ahead and do that here. So I have 2 pi over 3 equals 2 pi over the b. And some of you can just look at this and say, oh, b must be 3 in order for this to equal, right? But if you really can't do it that way, you can cross multiply, or if you want to, you can go ahead and switch it and put b up here and 2 pi over 3 down there. Either way, the b value is 3. Okay? For this to equal, that has to be 3. So we have our a, we have our b. We need our h and k, which is actually the starting point of this graph. So my starting point is this point right here, and that coordinate is negative pi over 6, 0. All right, I have everything I need to write my sine function. So our formula is y equals a, which is 1, so I don't actually need to write the 1, sine of b, which is 3, parenthesis, x minus the x value of the reference point. So that's a negative pi over 6, so we change the sign to positive pi over 6. And then the 0, you'd write plus 0, which we don't need to write. All right, so that's technically the equation of the graph, but I'm going to write it in our standard form where the 3 is distributed inside. So that'll be 3x plus 3 over 6 reduces to 1/2, so pi over 2. All right, the next one right here, we're looking for another sine function. So on this one right here, our a value is from here, oops. It's really dark in here when I don't move around. Okay, so here's where the midline is. So from that midline to the first dip going down, that's actually going a distance downwards, so that's actually negative. And a is a negative, this is going by 1, so negative 2. A is negative 2. All right, let's do the period. The period goes from this end to this end. How far apart is that? If I go from 0.25 to 1.25, that's the distance of 1. So remember the period equals 2 pi over b, and that's 1. 1 equals 2 pi over b. Multiply both sides by b, that'll bring that b up. So b is equal to 2 pi. Okay? All right, and then we just need our reference point. So our reference point is where this graph starts. And that point starts at 0.25, 2. All right, let's write our equation. So we have y equals, and then start off with our a value, which is -2, sine, and then we write our b value, which is 2 pi, times x. Opposite of 0.25 is -0.25, and then plus 2. Opposite same. We'll distribute the 2 pi here. So y equals -2 sine, and then we're going to multiply 2 pi times x, and that's going to be 2 pi x, and then 2 pi times -0.25, so that's like a fourth of this. So you can write, think of that as 1/4 and do pi over 2, or actually negative, I should say, negative pi over 2, because that's a fourth, 1/4. 2/4 reduces to that. Or if you want to, you can actually just write it as a decimal, plus 2. Okay. All right, let's go ahead and go up to here for cosine. So cosine, first of all, let's find the midline. This is our middle line right there. That helps us to figure out our a, and it starts up. So we know this is positive from here to here. That a value is a distance of, this is right here going by ones, so that's a distance of 2. All right, let's go ahead and find our period. So it starts here and it ends here. Looks like the distance of this is 2 pi over 3. So our formula is 2 pi over 3 equals 2 pi over b. Well, b is 3 again. All right, let's go ahead and figure out our reference point. Reference point for this is tricky. It is not on the beginning point of that graph. It's drop it down. It's where the open circle would have been when you graph it. That's the reference point, which is 0, 1. All right, let's write our equation. Y equals a, which is 2, cosine of b, which is 3, and then x opposite of 0, actually it's just going to be x, and then plus 1. So I'll rewrite this much nicer. Y equals 2 cosine multiply 3 times x is 3x plus 1. Okay. Let's go ahead and take a look at this one. Find the midline. So that's this line right here. That's in the middle. My value goes from here, and notice the point is actually right here. There's a dot right there. So from here to there is actually going down, and it's going by ones here. So a is actually -1. The period is going from here, -2 pi to +2 pi. So that's a distance of 4 pi. So 2 pi plus 2 pi is 4 pi. All right, to solve, it's 4 pi equals 2 pi over the b. Yes, technically you write absolute value b. I can go ahead and cross multiply if you want to, or if you want, do the swap thing. I don't know if you remember the shortcut where the diagonals can swap. So the absolute value b equals 2 pi over 4 pi, which that gets you 1/2. So b is 1/2. And then the reference point is actually not part of the cosine graph. It's where it is on the midline. Go ahead and put the open circle there. That's your reference point. That's -2 pi 3. All right, we have everything we need to write the equation. So we have y equals, and then a, which is -1. So I'll just put negative cosine. And then b is 1/2. And then we plug in x, opposite of -2 pi is a +2 pi. And then outside is a +3. And now I'm going to distribute that b value. Y equals negative cosine. Half of x, you can write 1/2 x or x over 2, it doesn't matter. And then half of 2 pi is just pi plus 3. All right, let's take a look at this next one. So for this one right here, I'm going to write the equation for the middle one. There are 3 options, but I'm going to go ahead and use the middle. So let's go ahead and first start off with our a value, and our a value is the distance from the center point, which is right here. I know that you see the point, that's not the center point, this is the center point. distance from here to here. And actually, it's not up to 2. If you look here, that's the y value, 3/2. So from the distance from here to here, actually I'll draw it out here, from here to here, that distance for A is positive 3/2. Okay? And then we want to find our period. So the period is the distance from here to here, and that's pi over 8 and another pi over 8. So 1/8 plus 1/8 is 2/8, and 2 over 8 pi reduces to basically pi over 4, or 1/4 of a pi. So that's your period, but that's not the b value. You have to solve for the b. Pi over 4 equals, and remember the formula changes for tangent. It's pi over b, not 2 pi anymore, because tangent's normal cycle is pi. All right, I know that these should match because that equals, so basically my b value is going to be 4 here. And then the last part is finding my reference point, and my reference point is the point right in the middle of the two asymptotes here, which is 0, 0. All right, let's write our equation. Y equals a value, which happens to be 3/2, tangent, and then b value is 4, and then x minus h and k, that's 0, 0, so it's just 4x, and that's it. You don't even need parentheses, you could just write 4x. All right, let's take a look at this one right here. So I'm going to go ahead and write this one right here. So first of all, let's go ahead and find our a value. So it doesn't actually show me, but you always kind of go to the right here. And if you look at what's in between these two, so kind of go in and in, that's in between. Where does it go down? That's the other point. So the dot's not there, but you can figure it out because you know it's halfway between here and here. So that right there tells me that the length from here to here is my a value. And the a value, this is going up and down by 1. So a is 1. Our period is the length from here to here. And it's going by halves. So if you don't want to have to do 9 pi over 2 minus 3 pi over 2 to figure it out, which you could, you can go, all right, this is going by halves. So 1/2, 2/2, 3/2, 4/2, 5/2, 6/2. And 6/2 is basically 3 pi. This is just a 3 pi. Or if you could tell, it goes skip 1 pi, so it's 1 pi, 2 pi, 3 pi. However you do it. Now that's not the b value, that's just the period. 3 pi equals pi over b. Okay? All right, so you can cross multiply if you want to here, or you can swap these two. I'll cross multiply since I did the swapping earlier. 3 pi times b is 3 pi b equals 1 times pi, and then divide by 3 pi. So this cancels, and the 3's left, but it's on the bottom, so it's 1/3 for the b. And the last thing I need is my reference point, which is this point right here in the middle of the two asymptotes. And that coordinate is 3 pi 1. All right, let's write our equation. So our equation is y equals, and then start with your a, which is 1, so I don't even need to write that. It's tangent. The b value is 1/3, parenthesis, x minus the h, which is 3 pi, and the parenthesis, then the 1 is outside. And let's distribute this 1/3 to get the final answer. So we have y equals tangent 1/3 times x. You can write it as x over 3. And then 1/3 of 3 is 1, so it's just 1 pi, and then plus 1. All right, and then the last part right here is, I'm going to use this one right here since I have those 3 dots. All right, it's up on the, oh wait, you know what, last one, oops, that should have been an a value, it goes down. That should have been a -1, guys. I just realized that. That's a -1, so I should have had a negative tangent. That should be a negative tangent, guys. Okay, this one's positive, it's going up. All right, so let's go ahead and take a look at the a value. So it's the distance from the middle point to this top. So how far apart is that? This is going by 3's. So up and down, this is a is 3, and it's going up, so positive 3. And then the period is the length between the asymptote to asymptote. So how far apart is this? So this goes by fourths. 1/4, 2/4, 3/4, 4/4. And 4 pi over 4 is just 1 pi. This is actually a normal b value, right? Because the period is pi, which equals pi over b, and b is 1 because it's a normal cycle. All right, and then our reference point is this point right here, which is pi over 4, 0. All right, let's write our equation. So we have y equals a, which is 3, tangent of b, which is 1, so I don't even need to write that, x minus the pi over 4, so minus pi over 4, and then I don't need to write anything outside the parentheses. And there's no b to distribute, so that one is it. Okay? All right. Hopefully you were able to follow along.